Hey guys, Beacon here. Today, let's look at a problem from today's Codeforces contest, Andrey and the escape from Capygrad. Now, if you read the problem basically says that you're on a one-dimensional line and you want to maximize your position. So you want to be as right as possible. To move, you can go through several portals. So a portal is defined as a pair of two ranges, where one range is completely inside the other. If you're in the outer range, you can use this portal and travel to any point inside the inner range. Now, after these pairs of ranges and these portals are defined, you're given a set of points, and you have to calculate the maximum position on the line that you can be after starting at those points that you're given and using the portals to move right. So how do we solve this problem? So if you look at this problem for a while, you might think that maybe these portals can be defined as like nodes, because after all, if the inner range of a portal intersects with the outer range of some other portal, then you can travel from that portal to the other portal, because you can be from that inner range to the outer range of another portal to the inner range of that other portal. So it's as if you can draw a directed edge from the first portal to the other one. So if you think of this problem as a directed graph, it's actually quite helpful, because after we define this directed graph, we can notice that, just like in a directed graph, we can find strongly connected components and merge them into like one big node. So a strongly connected component in a directed graph is like a connected component where you can reach, from every node, you can reach every other node in that connected component. So, for example, in the question, imagine if the inner range of two portals overlap with each other. That means that whenever you're in the outer range of one of the two portals, you can travel to the inner range of any of the two portals. Because you can travel to the inner range of one, then because they overlap, you can go to the inner range of the other one, and then you can just travel to the inner range of the other one as well. So essentially, if two portals' inner ranges overlap, we might as well as combine the outer ranges and inner ranges of these two portals, creating like this large big portal, because that will be essentially the same thing. You'll do the same thing. So how do we combine these overlapping portals? We can apply a classic algorithm of combining ranges. We can sort the portals by the position of the start of the inner range, and whenever like the two consecutive ones intersect, combine them. Otherwise, just insert the portal into the stack and then just consider the last portal on the stack and continue this process. So after doing this, we are left with a bunch of portals that have disjoint inner ranges. So no two inner ranges overlap with each other. So after reducing this problem to this quite nice setup, we can consider doing a similar thing as before. We can sort the portals by their inner ranges. And now consider a portal's inner range overlapping with some portal on the right's outer range. Now think, can you reach a position from the left portal's inner range that is further than the position you can reach from the right portal's inner range? No. Why? Because consider you want to go from the inner range of the left portal to some point more right than the right portal. That means that you have to start at the inner range of the left portal and move through portals to a position that's more right than the right portal. But that means the outer range of one of the portals you've used had to intersect with the portal on the right's inner range. So that means that you might as well as have done the same thing by starting in the range of the right portal, inner range of the right portal, and just doing the same thing, going to the same portals to the position on the right. So that means that a starting position that's more right is always more optimum than a starting position more on the left. That means that the two portals that we just considered, we can combine those two portals, because by combining them, the only other operation that we're adding is going from the right portal to the left portal, which we just proved is unnecessary and irrelevant, because any position you can reach from the left portal that's more on the right, you can reach from the right portal as well. So after combining all of these ranges and these portals, we are left with a set of portals that no inner range overlaps with another outer range. So now we can begin answering the question. If we consider a starting point, if that point is inside some outer range of a portal, we can output the maximum of that initial position and the maximum position of that portal's inner range. Otherwise, if it's not in any portal, then we just output that position. And with that, we're done. Thank you for listening, and I hope you enjoyed the solution. Thank you.